Well, what I've got for repair today is a Gould P884 power supply. These are the power supplies they used on the old Gould Multicon PLCs from the 1980s. I repaired one of these for this same company here about a month or so ago. They sent me another one, so I'm not really sure what's wrong with this one. They didn't send the key for the power, so I'm going to have to rig that up to where I could turn this thing on and off. I know the other one had quite a few problems with it, but I got it solved. So I'm going to pull this top cover off of here and we'll take a look inside and see what we have. Well, here's a view of the inside of this power supply. The last one that I got in had a tantalum capacitor that was burned up right here, and there was quite a few other capacitors that had some problems too, including these REFA capacitors were split open and bad. I'm just going to replace those as a matter of just because even if they haven't failed, they will. And this little, I think it was a 3.3 microfarad, if I remember right, 63 volt, it was basically completely open. So once I did some of that work to that other one, it seemed to work okay, but I'm not sure what exactly is wrong with this one yet. I haven't done any actual testing, so probably the first step will be, it's hard to get to that switch back in there, so I'm going to have to desolder all these leads. Underneath here, mounted on the heatsink, there's two great big DC to DC converters, and I'll have to solder those leads so I can get this circuit board up out of here. I did, on the first one, I did take the screws out in the heat sinks first and pull that whole thing up, but the DC to DC converters take up so much room, I found it was easier to unsolder them first. And I'll have to do that anyways, because in order for me to change these various capacitors, I have to get them unsoldered. So I'm just going to do that first regardless, and then while I'm in there, figure out an easy way that I can turn this thing on and off. Terminals on these DC to DC converters are pretty big and they take a lot of heat, so I've been using this particular soldering iron, which I don't use very often, with a huge tip on it, and I'll put a couple drops of rosin on there, and then I've got this really nice 6S wick that is probably from like the 1970s that I got off eBay, and it has a lot of holding capacity for the solder, and I found I just jammed that thing down on there good and tight like that in a very short amount of time with that big soldering iron, and with this really good wick, pulls the solder right out of that. There might be a tiny little bridge there now, but I'll get that with the smaller solder wick. But I've got quite a few more to go. I just thought that I'd show that. Well, that took a heck of a long time, like it did on the last one that I did. But I got those DC to DC converters unsoldered, and what I'll do is I'll have to do some testing here. I'll replace some components, then I'll drop this back down in and I'll kind of tack solder them on. It won't be nearly as hard to unsolder them the next time, and see what we have. You see where underneath this little insulator here, there's two pretty good sized bus capacitors there. I'll unsolder those and test them, see if they're leaky or good. I know on the other power supply, as old as it was, they tested really good. I did max voltage for each one of them for a couple hours, just to make sure that if they needed reformed a little bit, that they could do it. But there was no, even after like several hours, there was no leakage to speak of, so they were definitely good. But I'm going to start disassemble a little bit more, and then maybe you can see a little bit more what's going on here. Well, I've got that circuit board unsoldered. I got those wires disconnected. Right here is the on-off switch that I don't have the key for. I'm going to have to slit that shrink tubing and do the same for that one too, I guess. And, well, actually I maybe only have to do it with this one here, and then I'm going to have to reach way down in there and unsolder the wire from that side and put it on that side, and basically I just won't have an on-off switch. Well, I'm not necessarily certain that I'm happy with the outcome of that, but what will that will do is I will still have a fuse holder in line, and I'll be able to at least run this power supply now without having the key for the key switch. Before I put this back together, which I have to do a lot of testing over there first before I do, I'll wrap that with a couple wraps of tape, and of course before I put it back together permanently, it'll have another piece of shrink tubing over it. And, well, I got the insulator off the bus capacitor. That's a little bit of a pain, but you can get it off. There's the two bus caps. They're actually 1200 microfarad 225 volt DC, both of them. This leg here is nothing but a support leg. It's totally dead on both of them. I'll probably tomorrow, I think I'm going to wrap this up tonight. It's getting pretty late. I started on this pretty late at night, but I get those off of there and test them initially, and once I do get them off, there's other components underneath here that I can't get to right now that I can also test. And while I'm at it, these two Y capacitors, the REFA capacitors, I'll replace them as well. Even if these are good, it's just a matter of time before they'll fail. I have some good modern Y capacitors that should hold up a lot better than the REFA capacitors did. So we'll start back on this tomorrow and we'll see where we end up. So I've done some of the preliminary testing on this board, and I found that the only capacitor that I found that was bad was this 3.3 microfarad 63 volt, which was the exact same one that was bad on the previous power supply that I repaired. Still replacing these REFA capacitors, the Y across the line to the ground capacitors, because they fail constantly. I've got those replaced already. This 220 volt, 220 microfarad 50 volt capacitor, you can see it's worked pretty hard. I've got it replaced as well. Well, I finally got back to this after some time off, busy with other stuff. I've done quite a bit of testing on the main board, and I'm not really finding any bad components there. So what I did now is I swapped these two DC to DC converter bricks, and I'm going to see if the fault goes over to the other one. I have a feeling that maybe there's a problem with the DC to DC converter itself. I've got no output on the one. Now what I didn't have at the time either was the information on the input pins. There's kind of like a disable pin there that once I get this back together I can see if it's being disabled. But I found online a Vicor design app manual for a similar DC to DC converter with a number that's very similar to what I have, and there's quite a bit of good information on here, so I'm going through some of this and seeing if I can't figure out if maybe one of these has failed or not. I also did a little bit of tracing around, and I've got a few schematics drawn of certain parts of the circuit here. That way I can do a little bit more tracing. It's really hard to trace this. That main board's a double-sided board with these DC to DC converters soldered to the bottom of it. Some of the other stuff you just really can't trace things around very well. So once I had this apart, I went through and made a couple just minor schematics, just a few few areas to look at. I've got documented some of the power transistors that mounts along the side there too, what they are and where they happen to connect up to as well. So I'm going to solder this all back together and do some more testing and see if the dead 5 volts that was over here has moved over to here, because this is the one, the DC-DC converter that was over here. If that's the case, then that brick is dead, and I'm not sure I'll be able to get another one or not. I've got the 300 volts DC input to it. It says 270 on the tag. That's 270 minimum. It'll go from, you can have, at least according to this design manual, on a very similar brick, you can have from 270 up to 400 volts DC going into it, with 270 being the minimum. So I'm going to get this back together and plug it in and do a little bit more testing, and we'll see what happens. Well, this kind of proves that that DC to DC converter module, or brick, or whatever you want to call it, has failed. Previously, I had no voltage on this side. I have this plugged in right now, so I gotta be careful. I previously had no voltage on this side of the circuit, but I had voltage on this side. I swapped those DC to DC converters around. Now this side is dead, and this side has the 5 volts out. So that tells me that that converter's bad. I've got 300 and some volts DC in here, 307, and about 307. And also I notice that Vicor DC to DC converter design guide isn't exactly the same as what it is for this particular DC to DC converter, because when I go from in minus to gate in on the side, it doesn't work. It's 4.21 volts. So this must pull high when that circuit is no good. And the one that is working, the gate in is more or less low. It's in the millivolts. It kind of bounces around. But I've got, like I said, on this side here, I've now got my 5 volts. I didn't have that before with the other DC to DC converter. On this side, I think this very end one should have been a 5 volt. Maybe the next one over. Let me see here. I gotta be careful, these are close. Yeah, I got basically nothing. I've got nothing on all of this now. Previously I had several voltages there, because some of the circuitry takes that 5 volts and it boosts it, and it also drops it down depending upon where it happens to go. So that DC to DC converter brick is no good, and I really don't know if I'll be able to get another one. I found one of the ones that's listed in this design guide, but again, like I said, the gate in is pulled high to shut it off on this old one, and pulled low on the newer one, so it's not going to work. So this particular power supply probably is not going to be repairable unless I can somehow track one of those down. That's going to be doggone near impossible. I can't find any information on this particular power supply at all, other than the fact that it was in a Gould Modicon PLC. So that might be the end of this. We'll see, but I don't think I'm going to be able to repair this.